Okay, for those of you who don't know me, I'm Pam Marrone. I started my career a long time ago, more than 3 decades ago, at Monsanto Company. I was way ahead of my time. I screened over 100,000 microbes looking for natural products that can control pests in agriculture. They cut that program and focused on GMOs, and you know how successful Monsanto was with that. I left and started up Entotech, which was a subsidiary of Novo Nordisk, that's now Novozymes, and screened another 50,000 microbes developing biological pesticides. Then they sold us to our largest competitor, and I started up AgriQuest. AgriQuest, I raised over $60 million in venture capital, was taking it public, unfortunately right before 9/11, and the IPO didn't happen. So I left in 2006 to start up Marrone Bioinnovations. AgriQuest was later sold to Bayer Crop Science for almost $500 million in 2012. I had left and started up Marrone Bio in 2006 and developed a broad line of products at both companies, and took Marrone Bio public on NASDAQ, trades MBII today, and then I stepped down as CEO, retired CEO spot, August of 2020 last year, and now I advise many startups and still on the board of Marrone Bio. So what's in store for crop protection and pest management today? Well, things are very rapidly changing. So we're going from a chemical-intensive agriculture to a more bio-intensive agriculture. And when I'm out talking to farmers, they're now starting to ask, what does your product do, or what does a certain chemical do, or what does even your biological do to my soil and to the soil health? So we as integrated pest management practitioners are going to have to, and are, characterizing what our products do to that soil as we apply it to the farmers' fields. And some very exciting things are being shown. We're seeing that biologicals can lower carbon footprint dramatically, and we hope to get farmers to get carbon credits for that. We're seeing that there's an increase in soil microbial biodiversity and changes and positive changes in the microbiome. So you can microbes are increasing that sequester carbon, increase nutrient uptake, can increase biocontrol, microbes in the soil, and a whole range of other positive benefits. As we get the data, this whole area of the microbiome and soil health, and I know a lot of people are working on this, but the data's coming in and it's very exciting. Number two, there's a convergence of precision technology, the digital farm, and integrated pest management. No longer are we going to be able to be just product providers like my companies have been, but also the digital tools and the precision tools are available to help integrated pest management be better. For example, there's a company in California called Root Applied Sciences, and they do real-time PCR where they can detect in an automated detector a fungal spore that causes downy mildew of leafy greens or powdery mildew of grapes, catches the spore real time, and then has a very fast PCR test to detect and identify those spores. So then you can, instead of using degree-day models, which have worked well for a while, real-time the farmers will be able to know when the spores are there, then they can time the sprays a lot better. So not only will this help them reduce the chemical sprays, but also help them time biologicals better, which are typically preventative. There's a company also called Semios, that's from Canada, that has an integrated SaaS. So they have a prescription-based, subscription-based, and prescription-based farm management program that includes both the pest management and automated trapping of navel orangeworm and other pests. So no longer do the farmers have to walk their fields and manually count the bugs. They sit at their computer and the moths fly into, attracted by the pheromone, fly into the trap, which has a camera, takes pictures, tells you how many moths are in there, and then it'll automatically spray the right amount of pheromone. And combine that with the pest management and disease management models and weather and a whole bunch of other tech tools, and providing a subscription for the farmer. So this is where we're going with pest management. There's a whole bunch of other things I could talk about, but I'm going to turn it over to Chris for her to add in there.
Thanks, Pam. As Kathy said, I'm the director of the School of Integrative Plant Science at Cornell, but I'm also a plant pathologist. So hearing Pam talk about some of the exciting developments in disease control, I could not agree more. Some of the things that I see as innovations for the future in terms of pest control, as Pam said, digital ag is becoming not only useful for the largest farms, but I see it now as useful for all farms. There are and are becoming more cost-effective ways for people to use sensors and robots to understand, early detection of disease. I think that for all of pests, whether it's insects, weeds, or pathogens, that early detection and early mitigation is key. As Pam said, particularly when you're using biologicals, but in general, you're just going to be way more successful. So there are lots of folks now, several folks at Cornell, who are actually using imaging to then determine, based on this imaging, this hyperspectral sensor image that I have, I can tell that my potato plant has late blight and not early blight. Now, if I have late blight and not early blight, that means I'm gonna, use one control tactic versus another because one is an oomycete and the other is a fungus. And knowing that early on, and it's only on a small part of my field, I can go in, I can mitigate that. It really, as Pam said, will reduce the total amount of inputs and enable people to target those inputs at exactly the right time. One of the things that I'm really excited about is that I think that many of us are catching up, but are finally at a stage where we're really looking at the whole system of a farm. And every farm system is going to be a little different, right? The environment is different. As we know, for pathogens, the environment is critical. So we now have lots of projects where plant pathologists are working with the entomologists and the weed scientists and the soil scientists at that integrated pest management level to say, okay, at a system level, what's going to happen if my soil microbiome gets modified? Is that going to help yield, but is that also going to impact the environment? So we're going to have to think about this disease or this insect. So thinking at a system level, to me, is one of the most exciting things that's happening moving forward. And modeling how different applications will modify that entire system. And so to me, I see that as the future. I also see farm pest control strategies being more and more individualized. I completely agree, as Pam said, rather than, here's a chemical that we know controls this insect. It's, I know that 2 years ago when you grew broccoli, you had this strain of the pathogen. And it's really fairly cheap and inexpensive and effective for us to say, this is a strain of the pathogen you had. Chances are that's the one you're going to have this year. So we recommend that you plant this cultivar because we know it's resistant. So using all of our tools. The other area that I want to bring up before I ask Pam a couple of questions is that breeders are now, in fact, breeding to enhance the microbiome of the crop plant. And to me, that's amazing. Not only the root microbiome, but also the leaf microbiome. And for example, in apple, you might be looking at the flower microbiome so that you reduce the chances that you'll have that fire blight strike early in the season. So I think there are so many exciting opportunities. I think this is probably the most exciting time to be a scientist in pest management because we're moving forward so quickly. So Pam, one of the things I wanted to ask you is, have you or folks in your company seen dramatic changes in people looking at that system level rather than targeting, I want to target powdery mildew or I want to target aphids?
Well, out in the field, I'm hearing growers ask about it more and more because they need a comprehensive systems-based solution. So I'll give you an example. You may know that, of course, that citrus has been devastated by citrus greening vectored by the Asian citrus psyllid. So I was down in Florida talking to one of the largest citrus growers, and he said, well, look at over there, Pam. I can see that those varieties yield better than those over there. Oh, and I've tried this nutritional program and these biostimulants, microbes on this block, and look at how much better it's doing. And so he was begging for systems integrators. And what we're missing, and we're not trained, we're trained as entomologists or plant pathologists, and that's the way extension is also is siloed. This is changing because the growers, and not just a citrus grower, but growers in New York, wherever I go, are asking for the systems integration. Now that, as we've discussed, precision technology and digital ag is coming, imaging, robots, smart sprayers, drone spraying, I mean, so many different things that they're overwhelmed with all this technology. So we need systems integrators, both on the tech side as well as the bio side. So I'm seeing, yes, input companies, especially the big ones, well, not just the big ones, but even companies like Copert, which is a company in Europe that has been around for more than 50 years. They're incorporating, they sell beneficial insects and bumblebees and such for pollination, and they're incorporating a lot of digital and tech tools. So more and more we're seeing the companies becoming more systems-based and the growers demanding it. And so the land-grant system is going to have to change as well.
Totally agreed. Do we want to take questions from the audience?
We could.
Are you ready for a first question?
Sure.
So this one's for Pam. How does a startup with solid crop protection IP get institutional traction? Or how do we get farmers to adopt this technology?
Oh, the story of my life. Okay. Because I was way ahead of my time, I had to do this. I had to actually change the paradigm of how biologicals were used way back in the 90s. So now I'm helping a lot of companies go to market. And there's a plethora of companies, particularly in the biostimulant and bionutrient space, because it's less regulated, so there's more companies jumping in and more investors in that area. And they all have, a cocktail of microbes that, not all of them, but a lot of them have cocktails of microbes or something that are often very similar. And they say, well, I'm going to expect this many millions of sales in 3 years' time. I go, wait a minute. Your question was if you have good IP, if you have a differentiated technology, that is a great start because it's a crowded space, so you need something differentiated. You need something that has IP around it. And then the best, because it's very difficult to go through the traditional distribution channel, and they have their own proprietary products, and also they're overwhelmed by the number of companies that are coming to them, especially small companies that don't have a track record. They're not going to put their customers at risk with a startup that doesn't have a good track record. So the best way is really to go to the farmer directly with on-farm demos where you take a block, let's say 20, 50 acres of the traditional program, and then you integrate in your solution, pest management solution, biological, and compare. And the more demos you do, the more adoption you're going to get. And then that attracts you to the distribution channel because you've recreated the demand for them. And there's no real shortcuts unless you've got a silver bullet, a replacement for Roundup, which I've been looking for my whole career and getting close with Marrone Bio. And so it really is to do that grower demand creation and pull it through.
Our next question is for Chris. How does biological crop protection play a role in climate change mitigation?
Thank you for that question. That is a great question. So, bioprotection. I think that anything that we can do to reduce inputs and increase outputs is going to help climate mitigation, right? And the fewer times we have to drive the tractor across the field, the more we can keep plants and biomass sequestering carbon in the soil. is going to be helpful. And so anytime we can use a biological, especially a biological that might survive and grow on the plant and reduce the total number of applications needed, I think that will be helpful. Additionally, I really believe that identifying the smallest area of the field that is initially infected and really targeting only that area is also going to be a huge help. Anything that, again, anything that we can do to, reduce total inputs, increase the use of products that are less, have a smaller carbon footprint to produce, is really going to be wonderful. And one of the ways is to try to use those biologicals that are naturally in the area. And so, as I said, breeding for a healthy microbiome, that if you can breed, which has been shown you can do, breed a maize that will have a stronger, a more diverse and vibrant microbiome around its root system to start with, then you might need less inputs moving forward. And so I think that our breeding programs, in combination with using a really broad array of products at the system level, right? The more you can use to control more than one pest at a time is really going to help with climate mitigation.
Oh, I agree 100% with what Chris just said. And my company, Marrone Bio, got some data where we hired a graduate school of management at UC Davis to do a carbon footprint study of 3 products, 2 microbial insecticides and 1 plant-extracted fungicide, and showed there was a 60 to 90% lower carbon footprint. I mean, these products are, if they're extracting from a plant, they're using plant-based materials, and also if you're fermenting, you're using agricultural raw ingredients, raw materials in your fermentation, and then spraying out the waste. There's no toxic waste. Spraying out, we can actually spray the waste onto the farmers' fields. Very different than a synthetic, more fossil fuel intensive process.
Our next question came from Renee, and she's wondering for Pam, where do you see unique bright spots or challenges with biological adoption?
Yes, there's still some challenges with biological adoption. This is I live this, and I saw a Farm Journal Pulse poll of more than 500 growers not long ago, and more than half of the growers polled still had low awareness and low knowledge, low education on, were not knowledgeable about biologicals. It's a shocking number, but it's probably because there's a lot of row crop growers and that's changing, but most of the use of biologicals have been in specialty crops. But, so we have a lot more to do on the educational front, and that also speaks to the land grant. There's not that much proficiency in the land grant. Cornell is a bright spot for sure, in proficiency about how to use biologicals. They have unique modes of action. They're often slow kill. They might stop feeding, but the bug doesn't die for a week. So there's a big educational, they can't be applied and tested the same way as chemicals. So there's an education curve. The industry's working on it, but since biologicals are often the domain of smaller companies, we don't always have the resources to do all of that marketing, but that is changing. So number one barrier to adoption is education awareness. The products are getting a lot better as we have dramatically, there's tools now, so many tools, biotechnology tools that we can use to improve products in fermentation, manufacturing, formulation, and such. The products are getting better and better, and it's getting that awareness and education out there that's really the key.
Yeah, I agree with that, Pam. And what we found in several cases that highlighting farmers that are already using those biologicals. In particular, there's quite a few farmers that are using beneficial insects, and highlighting them and having twilight meetings on their farms are really outstanding ways. Farmers know their farms and can explain to others better than I can, certainly. And so those are really effective ways of transferring information and getting information out to a broad group of people.
Yeah, peer-to-peer is the best, yeah.
Are there certain crops that are better suited to biological crop protection or certain types of farming?
Well, I'll take that one first. Historically, biologicals have been used in specialty crops, high-value fruits, nuts, and vegetables. Why? Because these are residue-sensitive crops. So if you're exporting, and most specialty crops are exported from the, in the U.S., then the buyers are very sensitive to chemical residues, and you can spray biologicals right up to harvest. You can also spray in the morning in your grape vineyard and be back for powdery mildew and be back in the field in the afternoon. A real benefit for labor management with tight labor markets these days. And because of their complex modes of action, you can manage resistance, which often is a problem more in specialty crops than in row crops. So a number of benefits for the specialty crops. Now, this is changing where row crops are increasingly adopting biologicals. Right now, 80% of all corn and soybean seeds are treated with microorganisms and other biologicals for seed treatments, stacked with chemicals on the seed. Why? Because the biologicals offer a yield bump that the chemical-only seed treatments do not have. So pretty soon you're going to see 100%. Brazil has become the largest biologicals market on the planet, in addition to being the largest chemical pesticide market on the planet, have adopted biologicals very rapidly because of pest resistance. But it actually happened in row crops with armyworms, fall armyworms. So there's an example where adoption was very rapid when there was a serious problem that they needed to solve. And interestingly, the government provided funding for farmers' extension because of the serious need to actually train extension specialists regionally to help them adopt the biologicals. So some real great examples of how you can make it work.
Yeah, I totally agree. The other place where I have seen biologicals be incredibly effective is in controlled environment agriculture.
Oh yeah.
Because the environment is controlled by name, it enhances itself, or it lends itself really perfectly to the use of biologicals. There's a lot of beneficial insects that don't really like to be rained on. And in the greenhouse, that's not an issue. You can control the temperature, you can control the humidity, and really effectively use biologicals, whether it's to control thrips or spider mites or something like powdery mildew. It's really a place, and at least in New York, we're seeing an explosion of controlled environment, not only greenhouses, but in vertical farms and many indoor locations, and the use of biologicals there, I think, will be incredibly productive, useful, and effective.
Yeah, absolutely. That's a real, where they really shine, yeah.
And then our last question, is traditional indigenous knowledge being considered in biological crop protection?
That's a great question. I was in Chile, and I was visiting the UC Davis Center there, and we went out and talked to some indigenous farmers, and what was very exciting was they were showing us pepper and tomato varieties that never had pest or disease problems. Why? So then the scientists at the center were characterizing the endophytes, the microbes that lived inside these varieties, and they were saving the seeds and passing them on for generation and generation. And I'm on the Sustainable Pest Management Working Group in California that is trying to move California agriculture to become more sustainable. And we have a number of representatives of the tribes, local tribes, and they're also providing us some incredible knowledge of things that they have done for eons, and we're incorporating that into our report with all the very modern stuff we talked about today. So I'm very excited by that, and I'm sure Chris has a perspective on that as well.
Yeah, I completely agree. And I feel like there's so much knowledge that is yet to be gained. And I know that we have so much to learn. I as you said, continue to be impressed by the the knowledge, the cropping systems, the cultural practices, the ways in which things are harvested and dried, just information that they have that could contribute to so many areas of agriculture. And as Pam said, the vast areas of where we're getting knowledge from now is one of a really cool thing. So I think from indigenous communities, from people who have been farming for hundreds of years, to new farmers who are bringing a new angle on what they're growing. And then one of the things that has surprised me the most as an administrator is the breadth of locations where scientists and scientist grower partners are getting funded. Right? So it's from regional groups, it's from state groups, it's from industry, right? Our partnerships with industry at Cornell and other land-grant institutions across the country has never been stronger. And then we have new places that funding is coming in from. NASA. NASA is one of the largest areas of funding growth in my school right now, because people are using the satellites for remote sensing to determine yield, to determine soil health, to determine pest impact. And the breadth of knowledge that we are able to we're just beginning to gain is really impressive, and there's a long way to go.
We did have one more question come in from the audience. Renee was wondering, she said, thank you for sharing the information about Brazil, but what about China?
What about China?
Yes.
Interesting. So I've been to China multiple times, and there, at the time, it wasn't, well, before COVID, it was struggling with biologicals, because 70% of all chemical pesticides, most of them off patent, are produced in China. So it's a very heavily dominated, but there is a rapidly growing biologicals industry. They probably will be the biggest one someday. But what China did was, a couple years ago, passed a law that said if you are from outside of China, foreign company, you must generate your toxicology package for your biological pesticide or your chemical pesticide within the country. Well, it costs us about $750,000 for biological data package for the tox and ecotox. There's no way we're going to repeat that in China, so it basically put a halt to all of the efforts. So, not unlike what China does, they're creating their own homegrown industry. And so it may be some while before we can figure out how to bridge that and get in there. But it's going to be, like Brazil, it will be a very large market for biologicals.
Yeah, I can chime in and say that, probably up until 3 or 4 years ago, there were a large number of partnerships between, scientists at Cornell and across the U.S. and scientists in China, and there still are some, not as many. It's become more difficult. And there was a huge amount of shared data. And so I was sharing data about, here's the genetic diversity of powdery mildew on cucurbits in New York, and comparing that to the genetic diversity in China. And that was, and around the world as well, but that was really helpful, because to see, all right, how much are the pathogens moving between continents, and how much geographic separation do we still have? And then saying, okay, well, here are the control products that are effective here, and they would talk about what was effective there. And I really saw that as a path forward to saying, okay, can we really learn about what's working in different environments and very different agricultural systems? But because of political impasses, many of those connections have broken down. But I'm actually hopeful that we can begin to learn from one another around the world as to what will be effective and what won't.
Pam, Chris, I want to thank you guys for that conversation, and also what excellent questions from the audience.
Absolutely.
Thank you so much.
Absolutely.
Great.